we are given this 3 by 3 matrix. Luckily, all of these entities are either zeros or ones. So that should ease our calculation, matrix multiplication, right? And we are given a power 2025 minus a power 2020. What should this be equal to? Right. Clearly, a power 2025 and a power 2020, and the options that are given are in terms of a power 6, a power 5, etc., etc. Right. Clearly, there must be uh, there must be some pattern in this matrix multiplication. Right. For example, a cube, a power 4, then must be following some pattern. That's why a power 2025 and 2020 are related to a power 6 or 5 or 4, whatever. Let us see. Let us try to multiply this a with a. Let us see how does this a square, a cube, etc. will look. Okay. If you do the multiplication a square, what will it become? So 100 into 101. That is 1 into 1, 1 plus these two zeros. So that's why these two will anyway be zeros. So this will be equal to 1. Then 100 into 010. 1 into 0, 0 into 1, 0 into 0, all zeros. Right? Likewise. So similarly, if you do this all multiplication, a square we are getting as all ones in the first column and all ones in the second row. Right. Now, if we try to do a cube is nothing but a square into a. We can do a square into a or a into a square. It doesn't matter. Right. A square into a or a into a square. It doesn't matter. Right. This is ultimately a into a. Whether you do this first or you do this first, it is still the same. As long as we are not changing the order in matrix multiplication. Right. Matrix multiplication order means, so for example, A, B, C, we have to multiply. Whether you do multiply B, C first and then multiply the result A with B, C, that is fine. Or you multiply A, B first and then multiply with C, that is still fine. But at the same time, A, B is not equal to B, A. We cannot change the left matrix to right matrix. As long as you are keeping that order of left at left and right at right, that is fine. Whichever way you are multiplying, right? Whichever ones you are multiplying first. So similarly, a cube is this one, a square into a. This we are getting a cube as all same as a square except this one. This is becoming 2. Similarly, if you multiply this a cube into again a, we are getting this number as 3, everything else same. So there is a pattern. What is the pattern? A power n is n minus 1, rest all is same. Rest all is same as a. Right? So we can actually verify this using mathematical induction also. So how do we prove this? For example, 100, n minus 1, 1, 1, 100. If this is a power n, then a power n into a will do this multiplication 100, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0. Then we'll get, if you do this multiplication, 1 n 1, 1, 1, remaining zeros. Right, if you do this multiplication, we'll get this one. So which is nothing but a power n plus 1. Right, so that's how we can prove. We in fact prove this using mathematical induction. Right. Now we know a power n is this one. All ones and zeros except this second row, first column. First column. What does that mean? A power 2025 is n minus 1. That is 2024 here. Rest all ones and zeros. Similarly, a power 2020 is 2019 here. Rest all ones and zeros. Same, exactly same as a. Now, what is the difference of this? 1 minus 1 is 0. 0 minus 0 is anyway 0. So 2024 minus 2019. That becomes 5. Rest all will become 0. Now we can see the pattern. A power 6 minus a will also give the same result. A power 6 means 6 minus 1, 5. 5 will come here. And a power 1 means that is a. That is a or original. 1 minus 1 which is 0. That is this one. So everything will become 0 except this one. This element will become 5 minus 0 equals to 5. So a power 2025 minus a power 2020 is actually equal to a power 6 minus a. Right, we have clearly seen. So that's why the correct answer is this one. Correct answer is a. Right. Only little trick here is to understand that there is a pattern here and identify what is the pattern. Right, guys?